Our next characteristic of an atom is the fact that all atoms are neutrally charged, unless they've been said to be otherwise. So, for example, if I say, draw me an atom of copper. Now, I haven't said if it's positive or negatively charged overall, so you have to assume that I mean a neutral copper atom. All right? If I ask you to draw a carbon atom, and I don't say anything else, then you have to assume that carbon atom has a neutral overall charge. How does an atom obtain a whole overall net neutral charge? That's because we've got protons and electrons. The electrons being negative, the protons being positive. If we have equal values, equal quantities of both, they cancel out to a total charge of 0. So let's look at an example here. If an atom, if I'm looking at element number 5, that means it's got 5 protons. How many electrons will I have to have? 5 electrons. Very simple thing to do, and also an essential skill to be able to demonstrate on a test. So, 5. 5 protons, therefore 5 electrons. Now, let's do some more real-world stuff. Again, we're going to go straight back to the periodic table. I've taken that slice again. It's a sodium atom, our favorite. And we can see we've got the atomic number 11. That tells us how many protons. So I got 11 protons. How many electrons must I have to balance that out, to cancel out that charge? I must have an equal number of electrons to make sure that they cancel. Very simple. Next example here, we've got fluorine again. So it's atomic number 9, therefore 9 protons. Therefore, to cancel out the positive charge, that atom, to be neutral, would need 9 electrons as well. You can almost take it as if every atom is essentially starting off with a neutral charge overall. And with that said, let's go to our next video where we go into more detail about electrons and their shells.